All right, good morning, guys. This is the 7th, and this is adding, subtracting, and multiplying radicals. So we simplified radicals yesterday. You know how all that works. Again, you can do that in your calculator, or you can do it with a factor tree. I think today, for a lot of our stuff, especially the smaller two-digit numbers, you can pretty much do it really quickly in a factor tree, and typing into the calculator would actually take a little longer. But so our rule for adding and subtracting radicals, they have to have the same index and the same radicand. So really think of that radical, that square root or cube root or fourth root or whatever it may be. Think of that as a normal variable with an exponent, right? The index can be the exponent and the variable can be the radicand, what's underneath. So I would treat this as 3x minus 2y. Those are two completely different variables. There's no way that we can combine those yet because they have the same index, which is a 2, but they do not have the same radicand, what's underneath. So what we need to do first is simplify the square root of 27, which will give you 9 and 3, and 3 and 3. Our index is 2, so it takes 2 to pop 1 out. So the square root of 27 is 3 square roots of 3. We're going to leave it like that. We simplified that one. And then we'll do 12 as well, which will be 4 and 3. Again, it takes 2 to pop 1 out, so that'll be 2 square roots of 3. All right, so then we distribute, and again, treat it like a variable. So if this was 3 times 3x, you would multiply the 3 times the first 3, but you wouldn't multiply it to the second one, right? Just like you would do it here, and you wouldn't multiply it again to the x. So all I want you guys to do is multiply the coefficients here, the first two 3's. So that'll be 9 square roots of 3 minus 4 square roots of 3. And now, as you can see, we do have the same index, and we do have the same radicand. So again, treat it like a variable. If I gave you 9x minus 4x, that answer would just be 5x. So here, 9 square roots of 3 minus 4 square roots of 3 is just going to give me 5 square roots of 3. That's it. So we can keep going. I'm going to skip around and not do all of them because you do have the answer key down there. I'll do another one. I'll do number 4, and then we'll go from there. So I'm going to drop the 10 for 28. That'll be 4 and 7 and 2 and 2. Again, this is a square root. So we have, it takes 2 to pop 1 out. So that'll be 2 square roots of 7. Now notice that it changes to a cube root. That is 56, the cube root of negative 56. So we automatically know it's going to be a negative, right? And then we can break that apart as 8 and 7. 8 would be 4 and 2. 4 would be 2 and 2. So there's our group of 3 because it takes 3 to pop 1 out here. So we're popping out a 2, and we're left with the cube root of 7 on the inside. So be very careful not to write a square root there. It is actually a cube root. That's one of the mistakes that I myself make quite a lot. And then the last thing that we have is 175. So if we break that apart, that will be 25 and 7, and then 5 and 5. And again, we have a square root, so we're going to drop that 4. It takes 2 to pop 1 out. 7 stays on the inside. So we need to simplify first before we get down to combining like terms. Minus 2 cube roots of 7 minus 20 square roots of 7. Again, we're just multiplying the 10 and the 2 and the 4 and the 5. We don't multiply inside that radicand, or inside that radical to the radicand. So from there, you'll notice that we have 20 square roots of 7. The minus 2 cube roots of 7 we're not going to touch because it doesn't have the same index. But the other 20 square roots of 7 we can. So these are actually going to cancel out. 20 square roots of 7 minus 20 square roots of 7. And we're just left with negative 2 cube roots of 7. And that's it. And then I'll do one with a variable. Let's see. Number 6 has 2 of them that I need to simplify. So I'll do that. Also notice that we have a addition sign in here and multiplication. So obviously we're going to do the multiplication first. But we need to simplify. So a cube root negative, we know there's going to be a negative on the outside. 40 will be 4 and 10. 2 and 2 and 2 and 5. It takes 3 to pop one out because our index is a 3. And then if you're writing this down, you might want to leave a little bit of space because this one we still have to break apart. That is a 3 as an index, so we need to take away 1 to get it to be a multiple of 3. So again, 6 will be a multiple of 3. That's just like what we did yesterday. And I'm going to leave that line right there and go ahead and start doing this one. For 135, breaking 135 apart, that will be 5 and 27. 27 would be 9 and 3. 3 and 3, so there's our group of 3 right there. So we have 2a squared first, then we have a 3 on the outside, cube root, 5 stays on the inside, and then that'll be a to the third and a to the first. That's how we're going to break that apart so that we can get it to be a multiple of 3. So now all we have to do is take the stuff out, take our variables out. We did the numbers the first time. So we're going to do negative 2, a to the 6th divided by 3 is going to be a squared, cube root of 5a. That's all we have left inside. Plus, we can go ahead and make that a 6a squared to multiply that out. And then that's actually going to be another a right there. So let's go ahead, I'll just leave it like that for now. If you want to go ahead and multiply that out and make it a to the third, you can. But for the sake of you guys understanding what's going on, I'll keep it there. Okay, so we have negative 2a squared cube roots of 5a plus 6a cubed cube roots of 5a. So we have cubed in the first one and squared in the second one. This is completely simplified. There's nothing else we can do here. Whenever you're combining like terms, if I gave you negative 2a squared plus 6a cubed, you can't do that because the exponents are not the same. The variables are the same, but the exponents are not, so this does not work. It's the same thing here. Yes, we do have the same index. Yes, we do have the same radicand, but our variable before that does not have the same index, or does not have the same exponent. So we are completely finished here. Combining like terms, you have to have the same variable, the same exponent, the same index, and the same radicand. Okay? So from there, multiplying radicals. Here we're going to use the product rule, which you actually probably already know besides the indexes. So as long as they have the same index, as you can see right here, as long as they have the same index, what you can do is multiply them on the inside together. We did this before when we were simplifying radicals and solving by square roots a good bit. But, so for this one, what I would suggest, some people say that they should break apart 27, do that factor tree, then combine them. I don't think that's a smart idea because you're going to have to end up doing this factor tree method right here twice. So if you will go ahead and multiply them out, 27 times 5, which would give you 135, and then just simplify it once, I think that's going to be a lot easier than having to do it twice. So, factors of 135 are 27 and 5. We got that. 9 and 3, 3 and 3. It takes 2 to pop one out because our index is a 2. So I have a 3 on the outside, and the 5 and the 3 leave us with a 15 on the inside. That is it. For number 9, you do have the same index, so we can multiply them. And what we'll do with the 2 and the 5 is just multiply them like usual. If I gave you a 2x times a 5x, you'd multiply the 2 and the 5, right? So anytime you're in doubt of like, I don't know what to do with these radicals, treat it like a variable. What would you do if it was a variable? So from them, we have the cube root, and 9 times 24 will give you 216. The cube root of negative 216, which actually, that's a perfect cubed, and that will be negative 6. So our final answer here, with no radical at the end, is negative 60. Not too bad. So we're going to keep moving on, and let's see which ones I picked. I'll do 12 and 13. So for number 12, we're going to go ahead and multiply those together. That is a cube root of 270 and m to the 12th power. And that's literally the only new step that you have in this problem. Everything else is just simplifying, just like you did yesterday. So if you do 270, you'll be left with 27 and 10. That'll be 9 and 3, 2 and 5. We're not going to get anything out of there. So this is a cube root, so it takes 3 to pop one out. A 3 is going to be on the outside. The 10 is going to be on the inside. And that's actually already a multiple of 3. So m to the 12th power right there, we can go ahead and divide and make that m to the 4th. And that is our final answer, 3m to the 4th cube root of 10. And that's it. For number 13, that's it. So we have the same index, so we're good there. We're going to multiply those numbers out. It's a odd index, it's a cube, so we're okay with having a negative on the inside. That's going to give us 108 a to the 13th power, b to the 6th power. So we are multiplying those together and adding those exponents. 108, that could give us 54 and 2, 27 and 2, 9 and 3, 3 and 3. So if we're looking for a cube root, we have the negative 3 on the outside. The negative has to come on the outside. You can't leave a negative inside the radical in the radicand as a simplified final answer. So then we are going to have a 4 left on the inside, and we need to make these a multiple of 3. So it'll be 12 and 1, and b to the 6 is still a multiple of 3. So our final answer, once we divide 12 divided by 3, that'll give us a to the 4th. And then 6 divided by 3, that'll give us b to the 2nd. Cube roots of 4a, that is the only thing left inside there.